Hello and welcome to another Tech Talk presented by SingleSprout and Codesmith. Today we are joined by Eric Rodgers, who's going to talk to us about message brokers. Without further ado, I'll pass it on to Eric.
Thanks, Leo. Hi, everyone. My name is Eric. First, I'd like to start off by thanking SingleSprout for sponsoring this Tech Talk. And also, I'd like to thank all of you for being here. This afternoon, I'll be talking about message brokers. This will be a bit of a high-level general overview of what's really a pretty complex topic. And I'm going to move pretty fast because of time constraints, but I hope I can communicate the basics in a way that's easy to understand. And I'll illustrate some real-world use cases. So hopefully by the end of this talk, you'll have a general grasp of the topic. So first things first, what are message brokers? Message broker is really just another variety of software. You can download it and install it just like anything else. It's a software that exists to help developers create event-based architectures where large amounts of data are constantly streaming back and forth in real time. Any major website or app that has active comment threads like Facebook or Instagram, or that uses real-time location data like Uber and Lyft, or streams content like Netflix or Spotify, or any large online sales platforms like Amazon or Shopify, with all the constantly changing data they have to keep up with, they all use message brokers. Back in the good old days of the internet, when things were simpler, the standard model was basically client, server, and database. The database stored all the information, and the server existed to help the client interact with that data. That model is still very much in use, but it doesn't work so well for the more modern ways in which we interact with the web. These days, message brokers, along with microservices, kind of help blur those old lines by breaking up monolithic applications and large data stores into modularized components of the system. Data is thought of more in terms of events or changes in the state and is broken up and distributed across the system. These events or pieces of data, which are stored in objects with unique keys and some sort of payload, are called messages, or sometimes you'll also hear them referred to as records. So a message broker is like a bridge between applications. It acts as a middleware, a message-oriented middleware, taking data from one application, a microservice, or even from a hardware endpoint, and transferring it to another microservice or device. Not only that, but a message broker can perform actions on the data and even store the data if it can't be immediately delivered. So what do I mean by actions? One example that's easy to visualize, even if you aren't a software developer, would be to think about the various new smart devices that are using the internet every day to transmit and receive data. From cars and televisions to doorbell cameras and household appliances, et cetera, the Internet of Things, as it's called, requires software to communicate and to translate those communications. For a streaming platform like Netflix, their video files need to be transcoded for all the various devices and the different file types they require, as well as their different aspect ratios and screen sizes and resolutions. Smart devices from all these various manufacturers need to interface with servers and databases and the cloud and with other smart devices. Message brokers do all of this. And that's really just a minor example that hardly scratches the surface of how they're actually used and relied upon by industries and tech companies today. So let's dig a bit deeper into how this really works. There are two modalities that are fundamental to understanding message brokers. The first one is queues, and the second one is topics, sometimes also referred to as exchanges. The queues in message brokers store messages. Those messages are sent to the queue from a producer, which is often a microservice application with a first in, first out logic, until a consumer, which is often just another application, processes or consumes them, which means removing them from the queue. Only one producer can send messages to a queue, and only one recipient can consume from a queue. So this operates in a point-to-point way, or a one-to-one relationship between producer and consumer. Unlike REST APIs, though, the message broker guarantees that messages will not be lost in case of failure of the consumer, because they're stored safely in the queue. You can think of queues like this. Imagine messages to be a kind of like a bunch of texts that are in transit to your phone. Each text was sent specifically to you, and all those messages will arrive in the order in which they were sent. Even if your phone is out of range of service or completely turned off when the messages are meant to arrive, they will be stored for you in order in some sort of a queue. And when you have service again or turn your device back on, those messages will move from the queue to your phone in the order in which they were sent. And to take this analogy one step further, the delivery confirmations won't be sent back to the sender or senders until your phone has successfully gotten those messages, no matter how long that takes. Queues are actually so integral to message brokers that people sometimes use the words interchangeably. The MQ in the name of some popular ones like RabbitMQ and Amazon MQ stands for message queue, but they're actually much more than just that. And that brings us to topics. Topics behave more like a broadcast. They're basically a logical configuration on top of queues that form them into groups. Think of a topic like a category. Each topic can have multiple publishers providing messages to that topic and multiple subscribers consuming those messages. This publisher and subscriber relationship is often referred to as pub/sub. In this case, the publishers don't necessarily have to know or care how many subscribers will be consuming the messages, or even if they're successful. Each subscriber consumes a topic via their own queue, but they can do this on their own time without worrying about other subscribers. A good analogy here might be to think of topics a bit like blasts from an email list, or maybe more like Google Alerts or something. Any number of people can get the same alerts, and they can all read them or not on their own time. And the senders who published whatever it is you're being alerted about probably won't know who's receiving their updates and who isn't. So this is generally a one-to-many or a many-to-many relationship. From a developer's perspective, a topic could be an event that updates or changes a piece of the state of an application, for instance. Anytime that piece of state is updated, a message will be published to that topic via a message broker. And all the applications within the system that are subscribed to that topic will receive the update to that piece of state in their queue. So in this way, topics really help us implement this event-driven architecture that I mentioned at the beginning, where the component applications within the system, those microservices, are effectively decoupled and can communicate or distribute tasks asynchronously without depending on each other in order to keep functioning. In fact, they don't even have to be aware of where these messages are ultimately going or what file types or languages the recipients require. So I think you can see by now that microservices and message brokers really go hand in hand. In fact, the whole rise of containerized cloud-based architectures is dependent on message brokers. It's the message brokers that handle the communications between the various components of the system, or between local environments and the cloud in a hybrid cloud environment, or even between clouds in a multi-cloud environment. They're sometimes called the backbone of the communications network, but I think it's even more appropriate to think of message brokers like synapses within a nervous system. Finally, it's important to understand that message brokers themselves can be deployed with container services like Kubernetes or AWS and grouped into clusters, which makes them really scalable. In a broker cluster, each broker is connected to every other broker in the cluster, and they work collectively to deliver messages. These brokers can all reside on the same host, but more often than not, they're distributed across the whole network. So each broker can route messages from producers, to which it is directly connected, over to consumers that are connected to some other broker in the cluster. In addition to providing scalability, clusters can help ensure persistency of data. If any one broker goes down, let's say the host it's on crashes, then the other brokers in its cluster can still handle those messages. I like to think about clusters like miniature versions of the blockchain or Web3, if you're at all familiar with that. Each broker in a cluster would be kind of like a full node in the blockchain, which operates on its own server and stores and shares a copy of the data, so all the other nodes can stay up to date. And if any one node goes down, it's not a big deal because all the other nodes have the data and can still perform actions on it and share it. And it's really easy to scale up or down as needed, since all you have to do is add or remove nodes, or brokers in our case, to or from the cluster. So moving on, what are some of the most popular message brokers in use today, and how do they differ? 3 of the top message brokers right now are RabbitMQ, Redis, and Apache Kafka, although there are many others. Each has its own unique strengths and weaknesses, and those are important to consider when choosing which one you want to implement. RabbitMQ is the most widely used message broker today. It's utilized by companies like T-Mobile, Reddit, Accenture, and Robinhood, to name a few. T-Mobile, for instance, chose to use RabbitMQ with Kubernetes clusters when they transitioned from their old monolithic architecture to cloud services. And in doing so, they slashed their production cycles for launching new code from 7 months down to a matter of days. RabbitMQ was released in 2007. It was one of the first common message brokers to be created, and it's open source. It supports all major languages: Python, Java, .NET, PHP, Ruby, and more. It can be used locally or in a cloud environment, and it supports complex routing logic. The speed of a message broker can vary depending on a lot of other factors, but I've seen 50,000 messages per second mentioned as a benchmark for RabbitMQ. RabbitMQ's greatest strength is probably its reliability. It operates on a smart broker, dumb consumer model, which means it consistently keeps track of messages and their status. But this reliability comes at a cost and leads to its greatest weakness, which is its relatively slow speed. 50,000 messages per second might sound fast, but in terms of message brokers, that's actually pretty slow. Redis, which stands for Remote Dictionary Server, is used by companies such as Twitter, GitHub, Snapchat, and even our favorite Stack Overflow. Twitter uses Redis clusters to handle data for some of their most important use cases, such as impression and engagement data, ad spend counting, and direct messages. It's also open source. It can send millions of messages per second, so it's much faster than RabbitMQ or really any other message broker, but it's not as persistent. Redis is actually a bit different from most other message brokers. At its core, it's an in-memory data store. It can be used as a database or a cache, and it can also function as a message broker. But even though it's a database, it prioritizes speed over storage size. So if you're dealing with a lot of data, you'd have to use multiple Redis clusters, which can be costly. So Redis works best in cases where you want speed and real-time data processing, where your message delivery is virtually instantaneous, and where you're not as concerned with persistency. Finally, Apache Kafka, also just referred to as Kafka, is the message broker of choice for over 80% of Fortune 100 companies. This list includes Netflix, Spotify, Airbnb, Uber, Shopify, Etsy, LinkedIn, and many more. Kafka was actually created by LinkedIn engineers and was made open source back in 2011. It also supports all the major languages, and it can process about 250,000 messages per second. But like I said, that figure is really dependent on other factors. Its greatest strength is its persistency. It can store large amounts of data for long periods of time with very little loss. Another strength is how Kafka utilizes topics, the pub-sub method, to act as a distributed streaming platform. Uber uses Kafka clusters and its real-time streaming data pipelines to process trillions of messages and multiple petabytes of data every single day. Netflix uses Kafka not only for streaming, but for all of its studio-wide communications. Kafka is at the heart of the entire Netflix studio infrastructure. Kafka's biggest weakness, however, is that it lacks a complete set of monitoring tools. So whereas RabbitMQ uses the smart broker dumb consumer model, Kafka operates on a dumb broker smart consumer model, which means you can't monitor the status of your messages as effectively. Deciding which message broker to use is a serious consideration for any company, and it really just comes down to what you need to achieve. If you really need to keep track of the status of messages as they're delivered and consumed, RabbitMQ might be the best choice. For near instant data processing, where you can tolerate some loss, Redis would probably be preferred. And for handling large amounts of data, streaming data, where persistency is really important, you might want to go with Kafka. In reality, most enterprise-level companies, including all the ones I recently mentioned, are probably actually using some combination of message brokers to suit different purposes. So that's my really basic high-level overview of what message brokers are and what they do. There's so much more complexity to them and so much more to know, but I hope I've helped you to at least understand the fundamental concept for now. They're a pretty important topic to grasp when it comes to system design and working with microservices and containers in the cloud. And since that's where the industry's headed, you'll probably want to have a pretty firm understanding of them as you enter the job market. Or if you're already working in the field and your company's thinking about moving to cloud-based services. With that, it's been a pleasure talking to you, and thanks for listening. I went a little over my allotted time today, so I think I can only take one question. If anyone has one, please feel free to ask. Eli?
Yeah. Hey, Eric, thanks for that great talk. I'm actually working on a project right now with a team, and we're using REST APIs and a traditional database. And I'm wondering, at what point would it make sense for us to switch from that model that we're using to using something like message brokers in a cloud environment? And where can I get more info on that?
That's a really great question, Eli. Thank you for asking that. Using message brokers and migrating your application onto the cloud is definitely not necessary for everyone. There's a pretty steep learning curve, and it really increases your system complexity. I'd say, in short, though, if you're dealing with actions on your site that are really time and resource consuming and might even be blocking your users from interacting with your application, then you should consider looking into message brokers because of their asynchronous nature. Or if you can't afford to lose a user's interaction because some third-party services are down at the moment or whatever, a message broker would help ensure that the data isn't lost. If you want to explore more, I'd say maybe start with downloading and installing RabbitMQ first and playing around with it. You can spin up a local server and use the web UI, or you can just use the command line. The docs are pretty good for walking you through that. It's a good place to start because it's so reliable and you can really keep track of your data as you get used to working with messages. Then I'd say check out Kafka because it's just so powerful when used at scale. And their website also has some really informative videos about getting started with message brokers in general. I hope that helps. And it looks like that's it for today. So thanks again and have a good one.